All right, boys and girls, welcome back to the drive-through for our little 3-day weekend edition. Hope everyone's jazzed up for their weekend. Special shout out to the great one, MLK, who's just made all of our lives better, more fair, more intelligent, more inspired, more courageous. And I'm planning on hopefully demonstrating some respect to him by talking to my kids about him this weekend. So here we go. We got Optima Prime. This is the most embarrassing part of being a math teacher, is when other math teachers try to make math questions cool. So, whatever. But importantly, it's a she. Optima is a she. And she is building a robot, because girls build robots too. Of course they do. Of course they do. Of course they do. But anyway. And we're trying to figure out how much fabric she has, and the function of fabric is in terms of x. So A of x, where A stands for area, is just equal to x squared. How do you find the area of a square? You do side times side. What's it called when you multiply a number by itself? And that's why it's called squaring it. I hope you get that now. That's why it's called x squared. You're literally finding the area of a square. So what's the domain? Well, what does domain and range mean again? It's this stuff that you're allowed to use for your x values. That's the domain. And what you're allowed to get for your y values. That's the range. So what are our possible x values for this? No, you cannot have a negative number. X has to be positive. We can't have a negative dimension. I mean, we probably could, but then we would warp into another dimension. Okay? All right. So, match each statement about the area. So the length of each side is increased by 5. So if we take the length, which was x, and increase it by 5, okay, what will our area be? What's the area of that square?
X plus 5 squared.
Yes, it is. It's x plus 5 times x plus 5. So, as you said, that's B. That's what you said. That was smart of you. Okay? All right. The length of each side is multiplied by 5. Do you want it to be this?
No, wait, that's the wrong one.
Or do you want it to be this? Is it 5 times x squared, or is it 5x times 5x? See. The length of each side is multiplied by 5, okay? So the area is multiplied by 25, just so you know. Think about it. What's the area of a square whose side length is 1? 1. What's the area of a square whose side length is 5? 25. So if you increase the length of a square, the area gets much, much bigger, much faster. Okay, the area of a square is increased. The area of a square is increased by 5. What's that?
That would be A.
That would be D. Increased by 5. And the area of a square is multiplied by 5. Give me this one, Karsten. All right, you're all over that. You didn't get one wrong. That's awesome. All right. Oh, we got more, Karsten. Predict how the graphs will stay the same or be different. Well, rather than predicting, let's get our Desmos on, dog. Hashtag dog.
Why predict? What's the point in predicting?
Did you pull up Desmos?
No, I didn't.
Carson, you're slipping. I'm just joking. I'm just joking.
Desmos is right there.
Oh, I can hit that with my mouse. That's helpful. All right, here we are in Desmos. They might have just picked up that whole little conversation, but oh well. Let's toggle back and forth between the worksheet. All right, so we need 5x squared, x plus 5 squared, 5x quantity squared, x squared plus 5. So let's start with this. That's our normal x squared graph, okay? Now let's look at 5x squared. What happened to it? I don't think so. It's the blue one. It got narrower because it's growing faster. It's still a parabola, okay? Let's look at this one. What do you think is going to happen to this one? Still going to be a parabola. Oh, notice this. The plus 5 moved it left 5. Interesting. Why is that? Well, what happens if you put a negative 5 in for x? You get 0. Well, that's why that happened. The vertex shifted left to get it to be 0. Huh? All right, what's our next equation here? 5x quantity squared. Ooh, the purple one. Super fast. Remember, that's the same thing as 25x squared. So it's just getting big super fast. Now, what do you think x squared plus 5 is going to do, Carson? What did it do? The y-intercept moved up 5. Excellent, okay? So this is the great thing about Desmos, is you can actually figure out what the heck is going on very quickly. Okay, so what are some similarities? Well, parabola, 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 parabola. Facing up, facing up, facing up, facing up, right? But what are some differences? What did 5x squared do? Well, it grew faster, so it was thinner. Okay, right? What did x plus 5 in parentheses do, Carson? This is the tricky one, remember. It went left 5. Okay? What was this one?
This one got not as thin.
Even thinner. Very good. The thinnest of them all.
Yeah.
And what did this one do?
This one just went
Up 5. Okay? All right, Optina decided to test her ideas using technology. She thinks it's always a good idea to start simple. She graphs it. Okay, we're all over this. Up 5. We already got this. Okay, knowing that things makes more sense with representation, Optima tries a few more examples. So what's like x squared plus 2 and x squared minus 3, looking at a table and a graph. What conclusion would you draw about the effect of adding a number to this x squared, adding or subtracting? What does it do?
It changes how fast they grow.
No. What does this plus do? Come on, what's going on? Is this working? God dang, I hate this thing.
Sonic.
Sonic. All right, come on.
So
So what does this plus k do to the graph?
it makes it thinner or thicker.
Nope, you're wrong.
Vertex.
It's a vertical shift. It moves it up or down, right?
Oh, yeah.
Right?
It's the y-intercept.
That's the y-intercept, exactly. We just changed the y-intercept, okay? All right, after her amazing success with addition in the last problem, Optima decided to look at what happens with addition and subtraction inside of parentheses. Adding to the x before it gets squared, okay? Should we go back to Desmos or not?
Yeah, let's do it.
Let's go back to Desmos. So, clear, 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 clear. We got x squared on there, okay? What does x plus 3 squared do? What do you think, Carson? What's it going to do? It's going to go to the left 3, right? Bam. Okay. What about x minus 5 squared, Carson. What's that going to do? What's it going to do? Right 5. All right, got it. So this is a really key part of math for the next 3 years. It matters with circles and everything we're going to do. So I'm going to have to type this neatly. When you add or subtract numbers inside of grouping symbols, which are just this, the result is a left, right, which is called a horizontal shift. However, this shift occurs in the opposite direction that you would predict. I call this counterintuitive. Does that make sense?
Yep.
Okay. Optima thought that number 6 was very tricky and hoped that multiplication was going to be more straightforward. She decides to start simple by multiplying by -1. What do you think is going to happen to our graph when you multiply by -1, Carson?
It's going to go up 1.
Why would you think multiplying by -1 would make it go up 1?
Sorry.
What's it going to do?
It's going to be a negative.
What do you mean it's going to be a negative?
It's going to be
How is that going to affect the shape of this graph? A negative parabola. You're a negative parabola. Bam! Negative parabola. Maybe a downward-facing parabola? Or how about a reflection?
Oh.
That's what we're looking for.
Into my weaknesses.
Now we're getting tricky. Okay, so predict what will happen. Why does it have an effect? Well, this is an important thing for me to explain to you guys. So this creates a reflection across. You know, I always thought it was across. Not even a word. Across the x-axis. This occurs because of PEMDAS. Yep. PEMDAS. What am I talking about? Well, why is a parabola always facing up? It's not a joke, although it sounds like a joke. Why is it always facing up? Or why is y equals x squared always facing up? Why is it positive?
Because there's no negative.
Yes, there can be a negative. -2, 4.
Because there's no.
Answer the question. Think about it.
Because you're not multiplying by it.
Yes, you are. You are multiplying by something. X times x is x squared. What's a positive times a positive? A positive times a positive is a positive. What's a negative times a negative? That's why it's always going up. Because it's a negative times a negative. Well, why is this one, why is that going down? Because of order of operations. What do you do first? Exponents or multiplication? That's right. So in the purple equation here, if you put in a -2, what's -2 squared?
-2 squared.
It's +4.
Oh, yeah.
But then you apply this negative sign, which is multiplying by it, and that +4 drops down to -4. Does that make sense? Okay? Back to the tape. Almost done. Optima is encouraged because that one was easy. She decides to end her investigation for the day, but okay, so the multiplier A. If A is a big number, what does it do to our parabola?
Increases it.
It does increase it. So what does that do to the shape?
It makes it
Does it make it skinnier or fatter? No, wrong. Watch. Skinnier.
What if you did 100?
Well, let's do 100 if that's what you want to do. Because what is it causing it to do? It's causing it to grow super fast. But check this one out. You know what a satellite dish looks like?
Yeah.
So what if this A value is small? It makes it wider. All right, that's the end of the video, so let me type that in. If A is greater than 1, then our parabola gets what? If A is big,
Small.
thinner. If A is less than 1, the parabola gets wider. That's fine. Thicker's fine. Nothing wrong with thick. What? I can't say it yet, dog. You know what Jordan has to say since she's done with her first semester in geometry? Boom!